I want to make a small video. Well, as a small one. I want to do a couple of assembly cycles. Charging, discharging it, and to see what kind of imbalance of internal cells will occur in the cell collections. I'll do the first cycle. Now I will show the charge status. I will charge it. I will infect it every time with a charger configured the same way. Here, so that it's you see, now the cutoff is 1261 volts here. Well, as there are 3 by 4 and 2. 3 groups of 4 and 2 volts each. That is, it turns out that 12 and 6 volts are somewhere in the total voltage. Now it will be born, well, and I will put it on the category. And I'll see what it will be. Well, charge. I will immediately put it on the discharge after the so-called recharge takes place, so that, well, there are approximately the same data. The same initial conditions. Well, of course, if the battery stays there for a month, let's say it will have 1 or 2% discharge there. Not a big difference in principle, but nevertheless. So, the first cycle. Yes, the battery was born. I'm betting on the category. The bit total will be 7 amps each time. Here. Up to 10, up to 7.5 volts each time. That is, it will burst out completely, the full cycle will go away. Because up to 10 volts is an annoying tool, but I will be completely. Something doesn't want to. It doesn't hold. By the way, all amps. For some reason, the current. It doesn't hold. These contacts are terrible. It's high time to do something about them. I'll try restarting it. That is, everything starts up normally, turns off. It holds everything. It's just that something needs to be done with the load. Well, I'll probably do it in the next videos. The problem is that there is an oscilloscope on it, and some kind of here. The pieces of the microscope are worth the future, so any movement is fraught. Nothing, I'm breaking up, I'm looking. We will watch a few cycles of it all. To see the imbalance? So, continuing shooting, the discharge is over. 10.429 thousandths of an ampere-hour. So, I'm charging the battery again. Well, this is the second cycle, sort of. This power supply will turn on now. So let's go. Here it will be possible to see from below how much has gone in here in hours. It shows ampere-hours, in hours and farad, and degrees show. Well, the second cycle. Then there will be a discharge. This is what I put on the discharge for the second cycle. Let's see what happens. The battery was fully charged, of course. I'll probably just show you how I discharge. So, another cycle has passed. 10,386 milliampere hours. I'm putting it on charge again. So, a little bit, I raised the charge current to 4 amperes. Well, to charge it a little faster. Another charge-discharge cycle. Charged to the maximum, I put the battery on discharge again. All the same 7 amperes. The next cycle is over. 10,338 is visible. Here I am putting it on charge again. And it will probably be possible, after the next discharge of the charge, to evaluate what we have there. Well, there was a current right there, it was turned on right away. Therefore, it went straight to charging devices. We will continue after charging. So, I charged the battery again to 12 and 6 volts, here it is. And now I'm going to measure what kind of imbalance there is in banks. Here it will be necessary to open this battery, obviously, and measure it. Well, I'm just going to turn it off now, and put it on for a while so that it just stands. Here. And in about an hour, maybe 2, I'll measure what voltage there is. So, I continue with a short video. The battery was now charged. After that, I left him for a couple of hours so that he, as they say, came to his senses. Here we see how many we have: 12 and 63. And now I'm actually going to cut it. We will see this case. I have a film assembled, and we will measure what we have here on separate banks, so to speak. Here are the cans that you see collected separately, so well, that's the easiest way to get them. It's best to get it and try it on. So we look. So here it is 8 and 4 here, we have 8 and 4. Well, you see, it's connected here, you need to crawl up here. It will? So on the first group, 4,285. On the second group, 455. So on the third group, 2, it is necessary to get up. For 207. Well, that is, it is clear that the battery is unbalanced. To do this, it must be inserted into the BMS cotton wool. But not only for this, but also in order not to recharge the battery as a whole. Now we measure the resistance of individual blocks. What it turned out to be, we have 7 million obviously. It's so hard to see. It's hard to see. It's very hard to see. Unfortunately, the backlight in this whole device turns off quickly. And I can't see well without the backlight. We have 7.1.7.2 million. The next block is peak. Getting here is a problem. The next block shows what the hell you see. I can't get there and messes with these contacts, unfortunately. The next block has 13.2 million, as far as I can see. That is very, very different. Let's say it's twice as different. But it can be seen that it is 13, 12, 13, as much as 1/10 of a million. I finally caught it. Well, because it was very inconvenient here that everything was already sealed with film, and it was a continuous displeasure to measure. Well, the third block has 9 integers, and so again you need to turn on the backlight to see something. $9.2 million. That is, specifically 3 blocks differ from each other in this battery. Well, because here the battery is the same as it was. Some are not air-conditioned, some are old, some are pulled out with a laptop battery. That is, the tin is complete. Well, what else about this battery? It will be necessary to completely redo this case here. Where the pluses are welded, it will be necessary to tear off this entire tape, insert insulating washers there. Here. Well, and put the BMS. BMS is now ordered by her. When this BMSka arrives, I will shoot another part of the video of this. Here's about what happened with the BM. Well, for now, here's what we have. Thank you for your attention. Put your thumbs up. And see you on the channel.